Go do our thing, and about a little bit before 5 o'clock, I'm sitting at my computer, I'm getting ready for the day, I'm doing all the things, and I get the email that says, school has been canceled, and I was like, on Monday, honestly, my reaction was, no, I was like, it's okay. My first thought was, thank you, God, you are clearly taking care of me and all the calculus babies, because really what we need most right now is some rest. And we're all going to get some more rest, except for me, because I'm already down to the bottom of my really big cup of coffee, so I am jacked up on caffeine for the next like 9 hours. And I was like, that's fine, you know, did the things, I got some work done, I got caught up on things, I emailed you guys, all the things are good. Enjoyed Monday. 2 o'clock became nap time. 4:30 became wake up time. It was delightful. Tuesday rolls around, same process, same cup of coffee, same email at 5 a.m. saying school has been canceled. And at that point I realized God and I are not on the same page anymore. I'm like, what are you doing? What I need is more instructional time. I don't need more rest, I need instructional time.
What would have been your reaction had they canceled today?
My wife experimented with that because yesterday all of the north school districts started canceling, because I think they got hit harder and a lot of them probably suffered school damage. And so it was like, Katy ISD canceled for the rest of the week, Spring ISD closed for the rest of the week, and my wife's like, HISD has just announced that they're closed tomorrow, and in the middle of watching TV, I was like, come on, God, what are you doing to me now? And my wife was like, just kidding. And you're going straight to hell. I mean, I was just, it was me yelling at God. I'm like, we had an agreement. Anyway. Oh God. So with the days that I have left on this earth before I go straight into hell, we have to go light speed through this last topic. Now here is the good news. We have done all the heaviest stuff. We have done series, done. We have done parametric and polar, done. In my ideal world, we had 5 days in this unit, and one of those was a review day. And so when you sent me your email, I was like, no, I got a plan. I don't have a plan for losing 2 instructional days. I'm not going to go faster than what we need to.
We're gonna go fast.
Okay, we're going to go fast, but I'm not going to go faster. I don't want to lose anybody. We have 3 little ideas left, and I think all 3 are going to go very well because they're very process-oriented. It's just a process that you're going to follow, and we're going to do it, and all is good. Things that I need to make sure we are all on the same page with. We need to start the benchmark exam at 10 a.m. on Saturday, not 9 a.m. 10 a.m. Is 10 a.m. going to work? We're going to go from 10 a.m. until 2 p.m. The issue is we have the AP Summit, right? You went to the summit at Southeast. We have the next one this Saturday at Brays Oaks, and I need to be there to get them started so that the teachers go to their rooms, that the humans under the age of 21 then go to their rooms, and I stay for a little bit for like the latecomers to get them to the right place. At that point, I will leave Brays Oaks, I will come over here. Good news, there's a Shipley's in between. You will be well taken care of. And I will arrive before 10 a.m. and we will be in the cafeteria. AB students, BC students, testing in the same place, because although your tests are different, they are identical in terms of sections that you're working on in time. Everybody good?
The AD test would also end at the same time as the BC test?
Yes.
Okay.
So you're hooked up for a ride here and a ride home. Great. All right, and then I will grade all your exams this coming weekend. Monday, Tuesday, we're going to look at the free response, give you guys some feedback, have you work on multiple choice corrections, do all the things. Starting on Monday, your homework every single night is going to be the same thing. 3 free response questions. One of them an AB question, one of them a BC question, and one of them a series question. 3 free response questions every single night. We are only going to focus on free response. Okay? All right, so with that said, I think that's all the things. Today's topic du jour is called partial fraction decomposition. I will tell you that it is the most obvious of the integration strategies ever. It is a technique, but I want to be careful. It's a technique, not the technique. It is a technique. It is a new tool in the toolbox called partial fraction decomposition. And the key is this. You're going to be given a problem that looks something like this one, x minus 19 over the blah, blah, blah. And, well, if you didn't know anything else, what ideas are out there? If I just gave this to you guys cold, what would you think? You want to find an antiderivative? Yes. I want to find an antiderivative. What options are there?
Like simplify it.
Like maybe you like factor, maybe you look for canceling. Guess what? No canceling. Another option to think about in the integration toolbox? Not give up. I was hoping somebody was going to say
Substitution?
substitution. Now if you try substitution, you say, okay, I need a baby, right? The denominator is usually the baby, and what's the derivative there?
2x minus 3.
Okay, wow, so u is x squared minus 3x minus 10. du is 2x minus 3 dx. Why substitution fails and fails badly is substitution works well when what's left is like a constant multiple of this guy here. If we saw 2x minus 3, it'd be like, coach, I got it. There's the baby, there's the u, we're good. What if it was 4x minus 6?
Divide by 2.
Well, if this was 4x minus 6, then I would just double both sides over here and I can move forward with substitution. If it was like x minus 1.5, I could divide both sides by 2 and things would go well. But this does not go well. So here's the thing. If by some magic act you happen to know that this fraction can be decomposed, that's what we're doing here. We're doing a decomposition. What you're saying is, let me take this crazy rational expression and simplify it into 2 smaller fractions. Well, now what can I do? My integration rules say, well, I can make this 3 over x plus 2 dx minus the integral of 2 over x minus 5 dx. I hope everybody's okay. Other legal things I can do here? That 3 is a constant. I can take the 3 out, and I'm left with 1 over x plus 2 dx minus 2 integral 1 over x minus 5 dx. I would hope that 1 over x plus 2 is something that all the friends in the room know how to integrate. Brian, you're looking feel pretty confident.
Natural log of x.
I'm sorry, one more time?
Natural log of absolute value.
Oh, that's what I thought you said. Natural log of the absolute value of x plus 2. And that 3 is just there because it's a constant multiple. Minus 2, Anthony, how are you feeling about integrating 1 over x minus 5?
Natural log absolute value of x minus 5.
Yep. And that's it, we're done?
Yeah.
Right, plus, don't forget Charlie.
Yeah.
That's it, done!
Yeah.
Yay, hooray, we got it. Now, this might be an answer that the College Board gives you as a multiple choice option, but it might not, you're frozen. Because I know you see all the things all the time, but especially here in Logland. What are some ways the College Board is going to hide the answer? Anthony, what do you see?
I don't know if it's true, but I know you can do a natural log x plus 2 divided by x minus 5.
It is true that when you have a natural log minus a natural log, you can combine them using division. However, these constants are going to cause a problem. Anybody know anything legal you can do with the constants?
Multiply them so they have the same coefficient.
What do you mean?
So, see, I'm not sure if it's legal. So you get that 3 to be a 6 and that 2 to be a 6, and you can factor out that 6.
Oh, so now you're multiplying by random things just because. No, I hope no part of that felt legal. Maybe you're having chemistry flashbacks to stoichiometry when you started doing things on both sides. Maybe not. Okay. What's the thing?
You just put that 3 inside and have x plus 2 cubed. or the 2 to x minus 5 parentheses squared.
That 3 is a constant that you're multiplying the natural log by. The property of logs that I was hoping we were going to get to, and we didn't. That's okay. We're still, we got like water in our shoes. Okay, 3 times the natural log of all the stuff. You can bring the 3 up in front and say it's natural log of x plus 2, the whole thing cubed. The 2, same thing. Minus the natural log of x minus 5, the whole thing squared plus Charlie. Chepe, I want to get back to you now. You were really insightful that the fact that these weren't the same coefficient was a problem. Well, guess what? Now they are the same coefficient. And because they are the same coefficient, now you can do the thing you wanted to do earlier. Or maybe, Anthony, you wanted to do this earlier. Natural log of stuff minus natural log of stuff is the same as.
Oh, you're asking us?
That's what I thought. There was an implied question mark at the end there. Natural log of stuff minus natural log of stuff is the same as
Natural log of
natural log of
stuff cubed
the stuff cubed
divided by
divided by that stuff squared
Plus Charlie.
plus Charlie.
Super Charlie plus Charlie.
Just Charlie.
Okay.
So that's the antiderivative. Brian.
Are they gonna tell us that this equals?
Oh,
the other
thank
one?
you. Brian, one more time. You just asked the billion-dollar question.
Are they gonna tell us this equals that?
God, absolutely not. Right? This is sort of the mystery. You're like, but like, how do I go from here to here, right? This should be the big mystery. Now, once we get here, are all the humans in the room okay?
Yes.
Right? I can separate, integrate, do some log stuff. Depending on the part of the test you're on, you can stop here. If it's on the free response, there's no need to simplify. But any one of these 3 could be what happens with the multiple choice. Brian, thank you. This is the challenge. How does one go about rewriting this part here over here? And that's the process we're going to go through. Okay, so here we go. This is what's called partial fraction decomposition, and actually in some schools, not at Yes Prep,
Integration of parts.
that's tomorrow.
Oh.
Don't miss tomorrow. Don't pull a Roger.
Hey, Roger.
Partial fraction decomposition is actually taught in Algebra 2. Because it can be. Watch what's going to happen. Mr. Kurt. I'm sure he would have taught us. Okay, everybody okay? Now here's the thing. The part that I know for sure that I can do is I can factor this denominator.
Yeah.
And here's the thing. If I see the factors, I see x minus 5 and I see x plus 2, I'm going to classify this, and the classification is important. I'm going to say that the denominator has non-repeating linear factors. Linear, they are both degree 1. Non-repeating, they are different. Then what I'm going to do is I'm going to say that this fraction can be written as 2 other fractions, one of them having x minus 5 as a denominator, one of them having x plus 2 as a denominator. Right? Because think in the backward step, back in Algebra 2, you would be given 2 rational expressions with different denominators, and you get the common denominator. You say, oh, it's going to have x minus 5 as a factor, x plus 2 as a factor, x minus 5 and x plus 2. Jose.
So how do you not have this plus in the middle?
Great question. I don't, but if it's actually supposed to be subtraction, we're going to figure that out. Everybody okay? What I know for sure are the denominators. The only way this denominator comes into being is if those denominators are x minus 5 and x plus 2 in the non-repeating linear case. What's the mystery?
What's the numerator?
Yeah.
What's the numerator? So I don't know. I'm just going to call them A and B. I'm just going to say that that's what they are. From here, it's all algebra. What we're going to do is we're going to solve the equation. Solve this new equation. Now, we've been together for a long time. You guys know my history. You know about back in the day, in high school, running in the gangs.
Faction killer.
fraction killer. We're going to kill the fractions. How do we kill the fractions?
Multiply by the same denominator.
Multiply everything by the same denominator. And that same denominator is going to be
Well, for both of them.
x minus 5 and x plus 2. If I multiply both sides of the equation by x minus 5 and x plus 2, and this is algebra 2 stuff that you've done, and this should be okay, well, what do I get on the left? I get x minus 19 because this x minus 5 cancels with that one. This x plus 2 cancels with that one. These are gone, but now with this new fraction, I multiply both by x minus 5 and x plus 2. What happens now? I'm going to have a and x plus 2 because the x minus 5 is canceled. Now I'm on to the next fraction, where now what happens? The x plus 2's cancel and I have b times x minus 5. So I went from this much uglier equation to a much simpler one. We're okay? Your goal is to figure out what's a and what's b. Those are the mystery values. Whatever a and b are equal to, this equation has to be true all the time. For all values of x, x minus 19 equals a times x plus 2 plus b times x minus 5. A way to go about doing this is that if this is true for all values of x, so just a little note here, must be true all the time, or always, which implies for all values of x this is true. That's the key. If this relationship is true all the time for all the values of x that you could ever possibly pick, then choose a value of x that is convenient.
0.
0 is convenient. What happens if you let x equal 0? What happens on the left? Negative 19 on the right?
2a
2a.
plus negative 5b.
Okay, plus negative 5b, which I'm just going to write as minus 5b. Not bad, but I still have one equation and two variables. Give me 1 second. And you have no way of solving this equation because you have two variables. But this relationship is true all the time for all the values of x you could ever possibly want to pick. And Chepe, I know why you picked x equals 0, because x equals 0 is often convenient. But there's a better value to pick. Brian, what do you want to pick?
X equals 5.
What happens if you let x equal 5?
You give b minus the, oh, you cancel out the b.
That's the, so let x equal 5. Over here?
Negative 14.
Thank you. Negative, your number sense skills are so good. If x equals 5, negative 14 over here?
7a
7a over here?
0.
Ah, plus 0b. And I don't have to be pulling down Anthony level number sense skills now. I know what a is.
2, negative 2.
A is negative 2. And as soon as you know what a is, guess what?
Oh, so you
Right, you could go back to this equation and figure out b. Or, clever other thing that you could do,
Okay. X equals negative 2.
how about if you let x equal negative 2? Right, go back to the original. Negative 21 equals a times 0 plus b times negative 7. And I think what you get
Yes.
is b is equal to 3. And that shouldn't be a surprise because what did we know already? We knew because I handed it to you on a silver platter that these guys had to, this had to factor as 3 over x plus 2 minus 2 over x minus 5. You go back and you say, ah, I got it. So it's going to be negative 2 over x minus 5 plus 3 over x plus 2. This is not the end.
What?
This is not the end.
Flip around.
definitely.
I mean, you can flip them around if you wanted to, but this isn't the end. Why is this not the end?
That's not integrated.
You haven't actually integrated. What you've done is you figured out how do I decompose this fraction into two fractions, each with a linear denominator, so that I can rewrite the problem this way, so that I can then use my typical integration techniques and get to the final answer. What are the questions that are out there?
Is that it?
Is that it? Yes. For the non-repeating linear factors. And this is what is assessed on the BC exam. For those of you that are hungry for the more, we can have conversations about the more, but for the BC exam, it is non-repeating linear factors.
Same level.
Okay? All right, so with that in mind, see what you can do with this next one. And nobody chuckled at my little hamster here.
I got the fun.
I was cracked.
I had
Oh.
cheese, but no crackers. I was crack-a-lacking. It's not as funny if you have to pay for it. Okay.
That was funny.
Yeah, too bad. All right, and for my process people, you're like, I need to see the 19 steps to getting this done. Here they are.
19.
Okay, the 9 steps. But see what you can do with this next one. Tonight's homework is going to be 8 problems total, 4 open-ended, 4 multiple choice. Lowest common denominator.
I went to buy a TV.
Also the jokes here, son.
Okay, that was
Where you going? Oh, okay. That's done for this evening. So what you saw? What did you do this night? You can get a one.
I know, I know.
Real quick. Is everybody decomposing this correctly?
Yes.
-1/2 plus 2, +1/2 minus 1. You could write the t minus 1 first, of course, if you want to. What will not change, though, is that it's going to have to be 1 over t minus 1. And it'll be negative 1 over t plus 2. Nothing but some algebra here. And please feel free to do this as quickly as you can, especially on the multiple choice. There are students that I've taught before that as soon as they get here, it's almost like game over. They know exactly what's going to happen. The angels whisper to them, strange things happen. They don't actually bother writing the t plus 2 and the t minus 1. They figured it out that it's always 3 equals this times this plus that times that. They go there, they plug it in, they're done. Whatever. So let's integrate quickly. Can I roll over here?
Negative natural log t plus 2.
Negative natural log absolute value of t plus 2 plus over here.
Natural log of t minus 1.
Absolute. You said absolute value in there, right?
Yeah.
Okay, now one thing I don't like having the negative 1 first. That is going to cause me some problems when I start using my log properties. So maybe I want to imagine switching these so that the positive comes first. So it's natural log minus the natural log. Anyway, at the end, natural log of t minus 1 over t minus 2 plus c is your absolute best final answer. How many guys would have made it all the way there?
Wait, to simplify the version?
This one or this one doesn't matter to me. Okay, we're good? Tonight's homework, honestly, I just want you guys to get some practice with this. Okay? I'm looking at what you see right now, Victoria, and number 1, there's a mistake.
There's no homework.
I did not mean for the numerator to be 11 minus 15.
Oh, yeah, might as well just have -3 then.
By the way, it's just -4. Alright. Where is it supposed to be? Okay, so
11x?
I'm not that's why I want to be careful.
So we gonna do number 1?
Yeah, that's absolutely not what I said. It's not 11 minus 15. What are my solutions? It's 11. It is 11x minus 15.
It says -4.
11x minus 15.
Oh, there you go.
Okay, perfect. All right, we'll get going.
Oh, we're supposed to do it now.
Yes.
No. Oh, it's the perfect. No. I'll take care of it. This is why I got it wrong. I ended with
Me paper.
If you're looking for a challenge, feel free to skip straight over to number 4.
Which ones? Which are the ones for homework? Are the multiple choice homework?
I want you to do the 4, these 4, and those 4.
For homework.
Yep.
These ones?
Yep. And no one's backing up yet because we still have at least 4 minutes left.
Chip. Gotta run. Brian about to set the marathon.
Hey, hold on, Mr. D.
Okay.
So for the AP physics folks,
I
like,
know.
can we put our
Brian
AP
is so
physics
romantic.
survival guide in our AP calc?
It probably fits in quite nicely, doesn't it?
Like, are you okay with that?
Yes. I can handle the commingling.
Yeah.
Yeah, just put it in the back.
Yeah.
That's what I did.
I can pick calculus first and then this last.
You're like you wouldn't mind unless you are going to go.
Just give it its own tap.
Don't tell me.
Yeah. I'm gonna like integrate.
Anybody want to talk about the non-repeating linear situation? I thought we. Yep. Brian. Okay. Come on.
Is it gonna show up?
Yep.
Can I turn it
I
off?
like how.
Yep. You can turn it off.